All right, guys, so let's jump into section 4.1. And this one is a fun one. I like talking about divisibility rules. So let's talk about divisibility. Students will be able to understand and explain divisibility, factors, and multiples, divisibility tests for 2, 3, 4, 5, 6, 8, 9, 10, and 11, and the set of factors is finite, the set of multiples is infinite. Divisibility. An integer is even if it has a remainder of 0 when it's divided by 2. It is odd otherwise. So even means it's divisible by 2. All the even numbers 2, 4, 6, 8, 10, 12, etc. We say that 3 divides 18, written like this, because the remainder is 0 when 18 is divided by 3. Likewise, b divided by a can be written like this. We say 3 does not divide 5 with the symbol here. 3 with the same bar, but then a not symbol, like the slash. 3 doesn't go into 25. For any whole numbers, a and b, when b is not 0, b divides a if and only if there's a unique number, q, such that when you multiply that number times b, you get a. If b divides a, then b is a factor or a divisor of a, and a is a multiple of b. Those are a lot of terms to define. We can talk about them as we go through this example. So are these true or false? Does 3 divide 12? And again, we're talking about there's no remainder. And also you can think about it as you can look at the number that if I multiply this number by something, which is 4, I get 12. So this is true. Does 0 go in to 2? No. 0 times anything is 0. So I cannot put 0 into 2. 0 is even. Yes, that is true. 8 doesn't divide 2. That's true. 2 goes into 8. This would be true because 2 times 4 is equal to 8. You can think about it as it's kind of like part of the house. Like if you're going to think about the dividend inside the house and the divisor outside of the house. So kind of imagine if you're trying to do this. Does 8 go into 2? No, because 2 is smaller than 8. 2 eighths would be 1/4. For all whole numbers a, 1 divides a. Yes, because if you think about it again, 1 times what would be a? A. So that's easy for all non-zero whole numbers. A squared divides a to the 5th. Yes, because can I multiply something by a squared to get a to the 5th? Yes, that would be a cubed. Because a squared times a cubed, when we have the exponents, we add these when we have the common base here. So it would be a to the 2 plus 3, which is a to the 5th. 3 divides 6 n for all integers n. Yes, I could just say that's 2 times n. So 3 times 2 will give us that 6, and then whatever the number is will be multiplied by the 2 and the 6 as well. Three doesn't divide all these things here. Let's see. 5 times 7, that's 35 times 99. So as far as our order of operations, you need to multiply all these first before you add one. What's 99 times 35? 7, 11, 9 times 16, 14. Yeah, 1. A way to see if you divide something is you sum up the digits, which we'll talk about in a minute, and you'll see if that's supposed to divide 3. So if I add 6 and 6, that's 12. 13, 14, 15, 16, 17, 18, 19. 19 is the sum of these guys, and 19 is not divisible by 3. So that means that this 3 does not go in. So that's true. 0 goes into 0. No, because 0 times, say, 1. Okay, this one's tricky. 0 times 1 is 0, but you could also think of it like this. This is an undefined statement. All right, you basically can't divide something by 0. Okay, so anytime 0 is trying to be the divisor, it doesn't exist. It's not. For any whole numbers a and d, if d divides a, then n is a whole number, then d divides n. times A. In other words, if D is a factor of A, then D is a factor of any multiple of A. So here are properties of division. D divides A and D divides B, then D would divide A plus B. If D divides A and D doesn't divide B, then D is not going to divide A plus B. Let's think about this in a really simple way. Say that I had 2 divides 4, right? And 2 divides 8. Does 2 divide 4 plus 8? Yes, because the property of division, say I could actually separate those. So I could say 2 divided by 4 divided by 2 and 8 divided by 2 and add them together. But if I have this situation where it doesn't go into one of the terms, it's not going to go into both of them. So like if I had 2 and 2, 4 plus 3, this is not going to be divisible by 2 because 2 goes into 4, but 2 does not go into 3. And so 2 does not go into 7. If D goes into A, D goes into B, and A is greater than B, then D goes into A minus B. But in this case, this would be a negative number, so that's why the second one is false. If D doesn't divide A, if D divides B, and A is greater than B, then D doesn't divide A minus B. So basically they're saying I can do the same thing here with subtraction as long as this first term here is bigger than that term to avoid negative numbers. Classify each and define as true or false. If 3 divides X and 3 divides Y, then 3 divides X times Y. Yes, because there will be a multiple of each of those numbers. If 3 divides X plus Y, then 3 goes into X and 3 goes into Y. Okay, so the tricky thing about that is these are not if and only if statements, okay? So this is saying if they divide each of the integers, then they divide the sum. But it's not necessarily true for the opposite, right? So I can think of an example. 3, does 3 go into 15? Yeah, it's 5. But I could write 15 as 10 plus 5. Does 3 go into 10? Does 3 go into 5? No. So it doesn't work that way. You can't do it backwards, but you can do it. You could say it would be true if these two guys were switched. If 9 doesn't divide A, then 3 doesn't divide A. That's not true because 3 goes into things that 9 does not go into. 15, for example, 3 divides 15, but 9 does not divide 15. Sometimes it's useful to know if a number is divisible by another just by looking at it. For example, to check the divisibility of 1734 by 17, we know 1734 is 700 plus 34. And we know that 17 goes into 1700 because 17 goes into 17 and 17 goes into 34. So we know it's divisible, that sum is divisible. Another method to check divisibility is to use the energy division button on a calculator. Press the following sequence of buttons. If you press that, you will get quotient remainder. If the remainder is 0, that means it's divisible by that number. A whole number is divisible by 2 if and only if its digit is divisible by 2. So if it's even. So here's some divisibility tests. This is what I love teaching students, especially if you're going to teach anything that's getting close to learning how to factor in algebra. Like I have tutored kids for 20 years in all sorts of maths, everything from algebra to college level calculus, business calculus, and calculus 1, calculus 2, all sorts of math students. And I will say that students are often really weak in just knowing their factors and their multiples. So when it goes to factor things, when you're trying to solve an equation, whether that's in algebra or geometry or pre-cal or calculus, they have a hard time solving the equations because they don't know how to factor. And being able to factor is directly related to this, knowing what's divisible by what. So easy, even, it's divisible by 2, okay? A whole number is divisible by 5 if it ends in 0 or 5. A whole number is divisible by 10 if it ends in 0. Those are 3 of the easiest ones that most people know, that 10 goes into things as zeros, 5 goes into zeros and 5s, 2 goes into evens. A whole number is divisible by 4 if and only if the last 2 digits of the number are divisible by 4. So an example for this, 148. Is it divisible by 4? Well, are these last two digits divisible by 4? Yes. Hopefully all of you know 4 times 12 is 48. So if I know these last two digits are divisible by 4, even if I have crazy other numbers in front of them to check, I'm like, this is divisible by 4. That means this whole thing is going to be divisible by 4. A whole number is divisible by 8 if and only if the last three digits of the whole number represent a number divisible by 8. That one I don't use as much. I'm not usually trying to factor as large of numbers. A little bit more trial and error. For 8, it would be the last three digits. I'm going to talk about nines. Okay. I will throw in nines if we don't get to them. The nines are my favorite. Determine whether this is divisible by 2, 4, and 8. Is it divisible by 2? Is it even? Yes. Is this divisible by 4? Yes, because 28 is divisible by 4. You get 7, right? So you're checking these two. And then here you're checking for 8. So 2s are just checking that first digit. 4 is just checking the last two digits. 8, you're checking the last three digits. And determine whether this is divisible by 2, 4, and 8. Okay, so it's even, so yes, but 26 is not divisible by 4, and also 26 is not divisible by 4. So this is a way to see things are going to, if they're divisible by 8, they're also divisible by 4 and 2, which makes sense because 8 is 4 times 2. So that Venn diagram is helpful. A whole number is divisible by 3 if and only if the sum of its digits is divisible by 3. And a whole number is divisible by 9 if and only if the sum of the digits of the whole number is divisible by 9. So these are really fun for me. So if you notice all the nines, hopefully you were taught this trick when you were learning the nines. If I write out the nines, 9, 18, 37, 36, 45, 54, 63, 72, and 81, etc. Okay, hopefully you notice, what do each of these digits add up to? We each add up to 9, right? And when I was young, we did the finger trick like this, so I'm trying to do it backwards. So if we were going to do 9 times 3, we would count over 1, 2, 3, and then we would see that it's 27. And that works because of this, because of the sum of the digits are going to add up to 9 every time. So even if you have a really large number, you can add them all up. If the sum of the digits is divisible by 9, and you can keep doing it over and over again until you get just a single number, then you know it's divisible by 9. Same for 3. So if I have something like this, I'm like 3 plus 1, that's 4, 4 and 3, that's 7. So that's not divisible by 3 because it didn't work out, right? But if I have 3, 1, 2, is this divisible by 3? Well, 3 plus 1 is 4, and 4 plus 2 is 6, and 6 is divisible by 3. So that means this number is divisible by 3. So here's an example. I add up 1 plus 0 plus 0 plus 2, I get 3. And so then 3 goes into number. 9 doesn't go into that number because 3 less than 9. This one is divisible by 3 and 9 because when I sum up, I get 18. And 3 goes into 18, and also 9 goes into 18. And like I said, with the 9s, you actually can keep adding. So you could even stop, you could even go here again. And if you keep adding the digits over and over again, you should get 9. And if you don't, then it's not divisible by 9. The store manager has invoiced for 72 calculators. The manager can read what are the missing digits and what is the cost of each calculator. So we have that the number is x. So we're writing this with variables x 67.9y, or they multiplied it in 100. That's how many cents it is. Because 72 calculators were sold, the amount must be divisible by 72. So 72 has an 8 times a 9. So that means the number to be divisible by 8 and also divisible by 9. So that means that 79y, the last three digits here, to be divisible by 8. Remember, these last three need to be divisible by 8. And then it also means that x plus 6 plus 7 plus 9 plus y needs to be divisible by 9 because that's the rule for 9s. Only 792 is divisible by 8, so y equals 2. And the last digit on the invoice is 2. So then we know we can add up all of those together. We get x plus 24. Since 3 is the only single digit that will make x plus 24 divisible by 9, x equals 3. So it must be 362.92. The whole number is divisible by 11 if only if this is an interesting one. I don't usually see it used often, but basically you sum up the odds digits and the evens digits and you subtract. And if that number is divisible by 11, then it's the whole number is 6. If you know it's even, okay, and then you know it's divisible by 3, it must be divisible by 6. The 6 is 2 times 3. So for 6, it has to be even, and also the sum needs to be divisible by 3. So is this divisible by 2? No, because is that even? Nope. Is n in a 5 or a 0? Nope. 8. Is 583 divisible by 8? Well, no, it needs to be even. Does 10 go into this? Well, does it end in 0? No. Does 3 go into this? To determine if it would be 3, you would add 5 and 7 is 12, 19, 40, 21, that'd be 30, 33, 39, 43, 48, 56, 59. 59 is not divisible by 3. So it's not divisible by 2 or 3, so it's not divisible by 6. And 59 is also not divisible by 9. 11, what you do for 11 is you sum up the opposite guys. So 5 plus 7 plus 9 plus 6 plus 5 plus 3. So 5 and 7 is 12, plus 9 is 21, plus 6 is 27, plus 5 is 32, so that's 35. If I did that right, I'm doing this really quick. Now these guys would be 7, 2, that's 9, 12, 16, 16, 8, 24. Okay, and if I subtract these, I get 11. And that's divisible by 11, which means is divisible by 11. Okay, hopefully that was fun for you. Hopefully you learned something new. As always, attempt the homework and please reach out with any questions.